Hello everyone, welcome back to my channel Grow Up with Tafsi. So here I am with a new topic, that is first law of thermodynamics. So let's start. So before watching this video, please go to my previous videos, that is topics covering your system surrounding, your specific heat capacity, work done and different processes in thermodynamics. So after covering that, just come to first law of thermodynamics so that it will be easier for you to grab the things. So first come to the statement. What first law of thermodynamics says? So the very statement, it says that the change in the internal energy of the system is equal to the heat given to the system and the work done on the system. So delta U is equal to delta Q plus delta W, where U is your internal energy, Q is the heat given to the system, and delta W is the work done on the system. So first law of thermodynamics is otherwise known as your law of conservation of energy, which itself says that energy can neither be created nor be destroyed. What can it do? It can change its form. From one form to another form it can change. So today I will explain this first law of thermodynamics with a best example so that it will be easier for you to understand. Okay. So before going to the topic, let's have some basic ideas. What is system, what is surrounding, that you should know properly. So system is that upon which your work is done. Okay, it either receives energy from the surrounding or it releases energy from the surrounding. So if this is your system, we know that system plus surrounding is equal to our universe. Okay, so anything, if we will subtract from universe, that is if we subtract system from universe, what we will get? Surrounding. So surrounding is anything which we get after subtracting the system from the universe. So if you will take a kettle using which you make your tea or boil water, etc., so that is your system. Suppose this is a kettle, so this is your system, and if you are supplying heat, okay, this is your system upon which work is done. Everything outside is your surrounding. So this is your system. So here what I have taken is that I have taken a beaker. Okay, the water is there inside the beaker, or it is a kettle. So it is just take it as a first case. So when we heat the kettle, the water molecules which are within the kettle, it will set up in a random motion. And why it's set up in a random motion means it is absorbing some heat energy which is supplied here. So that is in the form of the delta Q. So after receiving the heat energy, the water molecules set off in the random motion, okay, inside the kettle. So just come to the second case. What second case says that? So in second case, you can see here there is a bottle, and to the bottle the balloon is attached, and the balloon is in a deflated condition. Okay, so in the bottle, inside the bottle, the internal energy is constant. In second case, you see, very important, it is very important. Now the bottle, we have not put the bottle inside the hot warm water. Okay, just the bottle is set in rest condition and the internal energy here is constant. So after, in the third case, when we put bottle inside the boiling water or inside the kettle, what happens? Now there is a change in the internal energy of inside the bottle. So you can see here how the first law of thermodynamics is experimentally verified. So when the bottle is kept inside the hot water, so there is a change in the internal energy of the system because there is a heat expansion and some work is done, as a result of which the inflated balloon which was in previous condition gets deflated. So this is the best example for the first law of thermodynamics. As you can see, after receiving the heat energy, there is a change in the internal energy of the system and some work is done, and you can see the deflated balloon gets inflated. Thank you. So अगर आपको मेरा ये वीडियो अच्छा लगे सो डू लाइक इट, शेयर इट, एंड अगर चैनल पे आप नए हो तो प्लीज़ सब्सक्राइब इट. थैंक यू.